Hello friends. In the previous video, we learned that sound is a form of energy that is produced by mechanical vibrations of different objects. Now, we would like to understand how do these mechanical vibrations reach to our ears as sound. So we want to study about the propagation of sound. But there is a problem, and the problem is we cannot see sound. We can only hear it. But somehow we need to figure out a way to see and understand the propagation of sound waves. Let us find out in this video of how sound waves reaches your ears. Now, the first thing to note is that when an object vibrates, it sets the particles of the medium around it vibrating. Let us try to understand this with an example. So if we take the example of a tuning fork, when it is not vibrating, we can say that equilibrium exists in the surrounding medium in the absence of vibrations. If we look at this fork over here and we are just taking some particles of air that is surrounding the fork, just shown over here, and this is primarily for simplicity. So the air particles that surround this tuning fork currently considered in a state of equilibrium. But when we pluck the fork, that is we move it, then this starts moving. Now, when the fork is set to vibrate, that is both the arms of the fork, the tuning fork start vibrating. These vibrations disturb the equilibrium of the surrounding particles. So let us try to understand this in a bit more detail. Now, this single particle, we are just considering a single particle that is shown over here. This single particle, which is adjacent to the tuning fork, it actually moves towards this side when the fork vibrates towards this side, right? So this particle disturbs from its equilibrium. This particle then, because it moves towards this side, it also exerts a force on this adjacent particle to it. Now, after displacing this particle, the first one, returns back to its position. And this continues all the way till the end. Right? So essentially what we are looking at is this disturbance of this particle in the medium because of the vibration of the fork, the tuning fork. So this tells us that sound travels as disturbances in the medium. So if you look at, again, that single particle example, what you can see that the particles are now distributed in different ways. There are certain regions where the particles are too close together, and then there are other regions where the particles are, further apart. Then again, there are regions where they are close together and farther apart. So this is what gives us an idea of how the sound waves travel. Right? Now, one important thing to note is that the particles that we have shown over here, they do not travel from the source, which is this, the vibrating source, to the listener. It is actually the mechanical vibrations which result in disturbances in the surrounding medium, that is these particles, that reaches our ear as sound. Now let us try to understand the propagation of sound waves in a bit more detail. In the last few slides, we just looked at some particles. Now we'll look at even larger number of particles. So fundamentally, we can think about sound waves as a series of pressure and density variations in the medium. What do we mean by that? Let's explore this in more detail. So you can actually visualize the sound waves as a series of compressions and decompressions. And what do we mean by compressions and decompressions? So here is an example of a tuning fork which is set into motion, and what you can see here is this columns of air particles surrounding it. Now you can see that again this is basically taking air is surrounding the the tuning fork. So air is a very common medium in which the sound travels. Now if we look at one by one, let's say when the fork travels towards this side, right, that it moves towards this side. So what it does, it's when this fork moves forward, it actually pushes and compresses the air in front of it, and this creates a region of high pressure, and this region of high pressure is known as compression. So this is how it is visualized over here. You can see that the particles are very close together in this region. Now in the second step, what happens is that the vibrating fork will move back to its position, and it will move even backwards, right? So that will actually create a region of low pressure, right? And this region of low pressure is known as a rarefaction or a diffraction, or rarefactions or decompressions. So what essentially happens is, as this fork keeps on vibrating, what you get is a series of compressions and rarefactions, and that is what basically leads to the propagation of sound waves. Okay friends, let us summarize what we have learned in this video. We discussed that mechanical vibrations cause the particles of the surrounding medium to vibrate. Thus, sound travels as disturbances of particles in the surrounding medium. And it is also important to note that it is the disturbances that travel into the medium and not the particles themselves. We also learned that sound waves are variations in pressure and density in the medium. The regions of high pressure are known as compressions, and the regions of low pressure are known as rarefactions or decompressions. So we can visualize sound waves as a series of compressions and decompressions or rarefactions, as is shown as this in picture. Friends, I would recommend you to click on the red button below and subscribe now to the channel, so that you will be instantly notified of whenever new videos are uploaded to the channel. Good luck, happy studying.